Hello, in this tutorial I will go through how to either create or input the vectors that are required for data projection in LAM analysis. I will first go through how to create vectors automatically with LAM. First, select the directory where your samples are. The most important setting for the vector creation is the vector channel, which should be a dataset of nuclear labeled data like DAPI or another high-density channel that is found everywhere within the sample. For proper vector creation, the samples should have been mounted for imaging so that they are as straight as possible and along the x-axis of the imaging plane. The most critical part is that each sample's beginning has the lowest x-coordinate value. If this is not the case, LAM includes a companion script, rotator.py, in the comp folder of the distribution, which can be used to rotate the coordinate system of a dataset. The script file contains instructions on use. If LAM is given vector files as input, the rotation of the samples does not matter. The automatic vector creation of LAM is performed with the vector loop functionality by clicking Process and then by pressing the Create Vectors button. Best approach is to first select the median vector creation option and then pressing Loop to create vectors using the given settings. Once the loop is complete, the created vectors can be inspected from the vectors.png in the samples folder of analysis data. All samples with valid vectors can be removed from following creation loops by selecting them in the vector creation window and by pressing Keep. After, the vector creation can be changed to the skeleton setting and another loop can be performed, again keeping the samples with well-fitting vectors. If needed, the skeleton vector creation makes an additional point to each samples folder to guide parameter selection. The skeleton vectors are created by following pixels in binary transformed image based on a scoring system that prefers pixels in the direction defined by earlier selected pixels. At times, branching in the binary image can cause the pixel selection to follow wrong paths. To counter this, most important parameters are resizing and smoothing. Selecting a smaller resize value drops the number of pixels and makes skeletonization faster and more effective. Smoothing reduces roughness in the binary image and lessens branching due to more even pixel erosion. However, these parameters can cause nearby segments to fuse in the binary image when the sample is curved. In these cases, the binary dilation parameter can be used as a more gradual method for reducing branching. If the scoring causes wrong pixels to be selected, the find distance parameter can be altered to control the selection distance for each step. In case the vector creation fails to produce a fitting vector, the coordinates can be directly altered within the vector file. Once all vectors have been created, the full dataset is ready for analysis. The vector files can alternatively be fully self-created and given as input to guarantee best linearization of the sample data. An easy way to create vectors is by drawing the vector on top of the microscopy image with Line tool in ImageJ and then exporting the line's coordinates. The self-created vector files must be placed in the sample folders just as automatically created vectors. LAM accepts the vector files in either tab-separated TXT format or in CSV format. If using CSV, the file requires two columns named X and Y for the respective coordinates. If using TXT format, the coordinates should be given without headers and with X coordinate in the first column and Y coordinate in the second. To ensure the vectors were exported correctly, use the LAM companion script manualvectorplots.py to make plots of vectors and channel objects. In the script, provide the path to the root of the analysis directory, input a channel name to plot under the vector, and give a proper header number for the data files. Then execute the script to produce plots in the samples folder. Once vectors have been created or given to all samples and the data has been structured as explained in the previous tutorial, the data is set for analysis. In the next tutorial video, I will go through the general usage of LAM.